Hello everyone, today we'll be talking about conic section from expanded equation of ellipse, and my name is Andrew Truong. So to start off, let's define conic section. A conic section is a curve obtained as the intersection of the surface of a cone with a plane. And since we are talking about ellipse in this video, let's also define ellipse. An ellipse is a closed curve consisting of points whose distances from each of the two fixed points known as foci all add up to the same value. So generally, when facing a conic section problem, you will often face a problem that is structured like this. ax squared plus cy squared plus dx plus ey plus f is equal to 0. This is the general form of conic section problems. Now, it may not always be structured exactly like this, but when you arrange the order, it will most of the time be like this. Now, just by looking at a general form of a problem, you can tell right away whether it is a circle, a parabola, an ellipse, or hyperbola. So if there are x squared and y squared and the coefficient of both of them are the same, including the sign, then you can tell that it is a circle. Now, if there is only one x squared or only y squared, but they can't be both, then it is a parabola. Now, when there are x squared and y squared, and the coefficient of both are positive but are different, then it is an ellipse. Now, if there are x squared and y squared, and exactly one of the coefficient is negative and the other one is positive, then it is a hyperbola. So if I look at the general form, you can see what shape the graph is going to be, but you can't exactly graph the equation yet. So in order to do this, you must turn the equation from general form to standard form. So the standard form of a parabola is x minus h squared is equal to 4p times y minus k. The general form of an ellipse is x squared over a squared plus y squared over b squared is equal to 1. And hyperbola is x squared over a squared minus y squared over b squared is equal to 1. And finally, the standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. So these standard forms of the parabola, ellipse, and hyperbola are only one of two standard forms. So since we are focusing on ellipse today, let's dive deeper into the ellipse. So there are two types of ellipse. There's a horizontal major axis ellipse and a vertical major axis ellipse. The horizontal major axis ellipse has the standard form of x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where a is greater than b. And looking at this equation, we can see that the center is h, k, and the vertices is h plus or minus a, comma k. And the endpoints of the minor axis is h, comma k plus or minus b, and the foci is h plus or minus c, comma k, where c squared is equal to a squared minus b squared. Now the vertical major axis ellipse has the standard form of x minus h squared over b squared plus y minus k squared over a squared is equal to 1, where a is again greater than b. And the center is once again h, k. And the vertices is h, comma k plus or minus a. And the endpoints of the minor axis is h plus or minus b, comma k. And the foci is h, comma k plus or minus c, where c squared is equal to a squared minus b squared. And this is what the horizontal major axis ellipse looks like. And this is what the vertical major axis ellipse look like. As you can see, the major axis is horizontal, and over here the major axis is vertical. So let's do an example problem. So example 1 asks us to identify the conic section, standard form, and then graph 9x squared plus 4y squared plus 72x minus 8y minus 176 is equal to 0. So first of all, we need to arrange this into a general form, and by doing so, we get 9x squared plus 72x plus 4y squared minus 8y minus 176 is equal to 0. And now we want to bring the 176 to the right side, so we add both sides by 176, which give us 9x squared plus 72x plus 4y squared minus 8y is equal to 176. Now we see that 9x squared and 72x both have a 9 in common. And a 4y squared and negative 8y both have a 4 in common. So we bring out the 9 and the 4 out, and we get 9 times x squared plus 8x plus 4 times y squared minus 2y is equal to 176. At this point, we can now complete the square, so 8 divided by 2 is 4, and 4 squared is 16, and negative 2 divided by 2 is negative 1, and negative 1 squared is equal to 1. Therefore, we have 9 times x squared plus 8x plus 16 plus 4 times y squared minus 2y plus 1 is equal to 176, and now we have to add what we added to the left side to the right side. So it is 176 plus 9 times 16 plus 4 times 1. Simplifying this equation, we get 9 times x plus 4 squared plus 4 times y minus 1 squared is equal to 324. In order to get 1 on the right side, we must divide both sides by 324. And when we simplify this, we get x plus 4 squared over 36 plus y minus 1 squared over 81 is equal to 1. And this is the standard form of an ellipse. And since the denominator of the y is greater than the denominator of the x, therefore 81 must be a squared, while 36 must be b squared, since a is always greater than b. And that means that this is a vertical major axis ellipse. So now that we know the standard form of this equation, we can use the standard form to graph this equation. So first of all, we need to find out what the center is. The center in this case is hk. H is negative 4 and k is 1. Therefore, the center is negative 4, 1. And a is 9 since a squared is 81, and b is 6 since b squared is 36. To find the endpoints of the minor axis, we need to use h plus b comma k and h minus b comma k. We know that h is negative 4 and b is 6 and k is 1. Therefore, our endpoints are 2, 1 and negative 10, 1. To find the vertices, we need to use h comma k plus a and h comma k minus a. H is negative 4, k is 1, and a is 9. Therefore, our vertices are negative 4, 10, and negative 4, negative 8. In order to graph this equation, we do not need to find the foci, so these are all of the things necessary to graph this equation. Now that we have all the necessities to graph this equation onto the coordinate plane, we just plot the points of the center, the endpoints of the minor axis, and the vertices, and connect them together to make the ellipse. So here we are. So as you can see, we have the center in negative 4, 1 right here, and these two vertices, which are negative 4, 10, and negative 4, negative 8. And these are the two endpoints, which are 2, 1, and negative 10 and 1. And it is all connected around, and it makes a vertical major axis ellipse, just as we predicted. Therefore, our answer to this problem is that this is an ellipse equation, and its standard form is x plus 4 squared over 36 plus y minus 1 squared over 81 is equal to 1. And we can graph this equation onto the coordinate plane like this. So that concludes our lesson for today. So let's recap on what we learned. We learned how to convert from a conic section equation from its general form to its standard form. And from there, we learned how to classify it as either being a parabola, a circle, an ellipse, or a hyperbola. And then if it's an ellipse, we learned how to classify it from being either a horizontal major axis ellipse or a vertical major axis ellipse. Then we learned how to find the center, the vertices, the endpoints of the minor axis, and the foci of that equation. And then finally, we use all of that information to plot that equation onto a coordinate plane. And my name is Andrew Truong, and I hope you learned something new today. Thank you for watching.